All right, welcome back. Today we are going to talk about network types. Last time we talked about network topology, which is how the networks are connected or wired together. And today we're going to talk about the network types. You need to know the basics of that. All right. Are we recording? Yes, we are recording. Cool. All right, so we're going to jump right to our presentation and see how long this is going to take us. And then today, one of the groups is going to join me for the lab. All right, so network types, computer network introduction. All right, definition. A computer network is, what is it, a computer network? A group of computers a group of computer systems and other computing hardware devices that are linked together through communication channels to facilitate communication and resource sharing among a wide range of users. Okay, networks are commonly categorized based on their characteristics. I'm pretty sure this slide is self-explanatory. Network types. We are going to tackle some network types and explanations thereof, such as LAN, which stands for Local Area Network, WAN, Wide Area Network, WLAN, which is Wireless Area Network, MAN, Metropolitan, storage or network systems area network, server area network, or something of that sort. SAN. Usually it is considered as storage area network. And VPN, which stands for private area network. And these are the networks we're going to take a look at today. Now, this is, I took a picture of my previous installation some years ago. This is the gateway or router, and it's done by Cisco. And you can see that, what can you see just by looking at those lights? When the system was powered up, then of course you get the OK light, which tells you that everything is okay. All right, now you can see that the WAN is connected. So this means that this gateway has found internet. It's connected on internet. And then you see LAN connections. We're going to come back to this. That means there are some LAN devices that are connected and communicating. And then some of the most important thing, especially if you're installing networks that have to do with corporate systems that are joined together, which we're going to analyze today, later on. That means that this system has found its virtual private network. Okay, so this is kind of when I was installing systems and I would boot those up. First, I would look if it found internet. That means the connection is okay, and then a couple minutes later, this thing would just go and do its magic and the VPN light would come on. That would be a good sign. That means that we are online as intended. All right. Okay, so first thing we're going to take a look at LAN. That stands for Local Area Network. Now, LAN connects group of computers in close proximity within the same facility. A building or a group thereof. So it's a small, relatively small to other networks. However, it's one of the most common networks that you would be dealing with when you go out there to the big world and find jobs. It is impossible for us to exist without networks or local area networks. Can you imagine a building without plumbing? Can you imagine a building without electricity? Up till, I would say, late 80s, you could imagine a building, corporate building or office or some sort of business without local area network. Now it is impossible. So there are jobs out there, okay, when it comes to servicing networks. It's not a luxury anymore to have a network. It's a necessity. A building or office building, corporate building, a company cannot exist without having some sort of a computer network. All right. The purpose of local area network is sharing resources and services such as files, printers, applications, email, or internet access, and many more. All right, this picture you remember from previous presentations. This is the basics of how local area network is. Thank you. I just got a cake served. All right. Okay, let's get back to the. Thank you very much. All right. All right, so this picture here, that's the basic of the network. There's a patch panel or some sort of a LAN room or working wiring closet that this one is labeled as, where all the wires that are connecting the hosts or nodes or otherwise devices, all those wires, I remember from previous lectures, we say that those wires home run to a common location. Okay? So you can see that those wires run home. All the wires home run. They are installed in a home run configuration, which means there is no daisy chaining between devices and then the last device goes to the common communication closet. No, all the wires, each individual wire, home runs to the, wow, it must be the cake. Home runs to the main location here, okay? Now, let's keep going. All right, one network can consist of multiple LANs working together. Some of the bigger companies, bigger offices, bigger facilities consist of the whole local area network, which is like a big network. It can consist of multiple sub LANs, okay, such as there could be a separate LAN designated for accounting or, production plant or management offices. Okay, again, the big LAN can consist of accounting, production plant, management offices. These different departments can be on 3 different LANs or sub-LANs within the same company. Okay, so one big, huge LAN can consist of multiple sub-LANs, just something to keep in mind. Okay? All right, local area network, there's another look at that. There could be one company that could be consisting of not just one building, and I just want you to know how those sub-LANs or different parts of the LAN, it could be same LAN, but they could be connected within different buildings, and we're going to use some of the knowledge that we already gained from our previous lectures just to analyze this particular situation. All right, so I just put this thing in red here. A local area network connects a group of computers in close proximity within the same facility, such as building or group of buildings. Now, I just took a snapshot of Google Maps here. There are a couple of buildings. I just found some sort of 2 buildings that I'm not even sure where that thing is. I'm not even sure what buildings these are. These are just 2 buildings. I found a picture that has 2 buildings. Now, let's just say hypothetically, for our training purposes, that this is a big factory or something like that, and these two buildings belong to the same company. In reality, there could be two different buildings, but let's just say this is the same company, and these two buildings have to be all the computers in this building and all the computers in this building, they have to be connected on the same network. However, we have a separation here because we have two different buildings. So let's just analyze some of the solutions that could be implemented in order to make this as these two buildings part of a same network. So here are these two buildings. Now you're going to see, okay, see that red line is going to appear. Those two buildings can be connected in various ways. Let's say there is a trench that can be dug underneath the two buildings. And over here, we could have something, let's say fiber optic link or optical fiber link. How would this be connected? Right? Well, there would be some communication closet somewhere here in this building, and there will be some communication closet somewhere here in this building. Now, all the devices are connected to the main patch panel, and the main patch panel is patched. All individual computers are patched to the patch panel. From the patch panel, they are connected to individual ports. Every single computer or node or any device through the patch panel is connected to each individual port on the switch. Okay. Now the switches can be cascaded together. Remember when we talked about the topology? So the network can be connected into the patch panel in a star configuration. And the switches that are cascaded together, they could be connected, let's say, in a ring topology. Okay. Now, so let's just give a bit of a visual here. Here's the first building closet. Can we see things? Yes, we can see things. All right, so here's the equipment rack, okay? And it has many switches, okay? These are switches, and these switches would be connected in a ring topology. So now we have that connected, and there would be computers all over the place, and they will be connected in a home run configuration star topology to the switches, wherever the patch panels within patch panels are connected to the switches. Now, somewhere on the bottom or usually on top, there would be something that would be called a media converter. Media converter. All right. There will be a media converter. Now, that media converter would convert the output of the cascade of those switches onto itself. It goes to the media converter. Now, the media converter can convert the signal into many different ways of connecting with another media converter that would be serving another building. And these will be switches that belong to the other building, and there will be computers that are connected into the switches. Here, and the switches, of course, are connected with each other, and output of all those switches is connected, right, to, or output, you know, there's a link that is connected to the media converter. And, excuse me, the two media converters are going to be linked together. The media converter can convert the Ethernet signal from this building and the Ethernet signal from this building to, let's say, high output copper wiring, which is not likely or less likely. More likely, it would be optical fiber connection or it could be a wireless LAN, wireless device. So it could be connected to a fiber optic, and the fiber optic can connect these two media converters. So the electronic signal, or the electric pulses signal, the Ethernet type of signal, gets converted into fiber optic light pulses. And from here, same thing happens. These
Question,
two.
sir.
Hello?
Question. Yep. I have a question.
Okay, there's a question.
The media converter, like how many devices are running on it? Or is it just the box?
The media converter would be connected to as part of this whole system. So it could convert, it could gather all the signals that are coming from this cascade of all these switches, and it can connect the convert the signal into the fiber optic line. So there would be a lot of data traveling. All these data can be bundled up and shot right into the media converter. So it would service all the whole rack. Right? Same thing as here. Fiber optics bandwidth is much larger than the copper bandwidth. So that's why we are able to get all the computers communicating with each other, and all the computers communicating with each other here, and they could be converted into the fiber optic, and that could be a link communicating. So so this computer here, if you want to communicate with this computer here, it would basically see no difference in speed or the bandwidth as if it was communicating with this one here. Yeah. Did I answer your question?
Yes, sir.
Okay, thank you. Great. All right, so now the media converter converts to different media. So it could be over here, we always have Ethernet, because most of the time we have, well, unless we have fiber optic networks, which is possible as well. Okay? But for the most part, we're going to have this thing as Ethernet, copper connection, and that media converter can convert into a fiber optic or wireless or copper, but high bandwidth copper, but which is less likely. Okay. All right. So here's the situation in our PowerPoint. Let's just get back to that. Okay. Now, so this whole building could service as one local area network. And here's the situation that these two buildings can be connected through a media converter. Also, you're going to find media converter coming in from outside. Let's say there will be a fiber line going from outside, from the city, whatever the company is, and the fiber line can be coming into here. And then there could be a big media converter that would split the fiber optic signal into internet, telephone, TV signal, and whatnot. So that would be the job of the media converter, is to connect the one type of signal onto another, or another signal or signals. Okay, so there could be a, yeah, so that's the idea of a media converter. There's no one type of media converter. A media converter is a device that converts. Now, another way to implement a media converter is, you see it all the time when you go to Tim Hortons, your favorite donut shops, otherwise, Burger King, McDonald's, all the fast food places. When you see those menu boards, which are behind the counter on the big wall that advertise the products and so on, those menu boards are basically television sets or monitors, right? And those monitors have either, well, a few years ago, there would be a lot of external media converters. It would be just a box size of a double wallet, and it would be stuck at the back of the monitor that would convert the signal that would go from network onto the menu board, and then they would be synchronized together, so they could work as each individual monitor, or they could be interconnected. So let's say that there's a ping pong ball that bounces and it just continues from one monitor to another. So those monitors also have media converters. Now, as years went by, a lot of those media converters would be into media converter cards. So there would be not external box, but there will be a slot to insert the media converter, but still be a media converter. Right now, those monitors are built as menu boards. So the media converter is part of the monitor, and all you have to connect is the Ethernet jack, just like a computer jack, and plug in the computer cable or Ethernet cable. Okay? So there are many different implementations for the media converters. Yeah? All right. Now, I wanted to stop and give you this information because if you go into the industry and deal with this type of installations, there's a high chance that you will. I just want you to know the terminology of what things are. Yeah? How exactly they work, you might not need to analyze that, but you just need to know how they are connecting and what the purpose is of those devices. All right, so those buildings can be connected through a fiber optic, or they could be connected wirelessly through the antennas. And there are, depending on, sometimes it's easier to dig a trench or lay a pipe, or if there's new construction, there could be a conduit provided for this type of purpose. Or if it's a retrofit or installation of the buildings that existed, sometimes it's just easier to install wireless link, okay? And then you would connect different type of media converter when it comes to that. All right. Now, LAN cable structure example. When you go out to the industry, I just wrote a little thing here that says not all networks are up to highest standards. Some service calls will look like this. All right, so what do we have here? This could be a small shop. I took a picture of sometimes when I would go and do service calls, I would just take pictures for myself, and sometimes I would be required to take pictures, and most of the times you will be required to take pictures and submit them as your work report on the job completion. Okay, so this would be a picture of some sort of a small company. Was it a tire shop or mechanics shop or some sort of a small shop? What do we see here? But we still see the elements. Where do you see it? These would be home run wires that you see here, that all that spider web. Those wires go in the wall, up the ceiling, and they terminate somewhere at the desktop location of whatever the computer stations are. And they are terminated right into those the cascade of jacks. This group of jacks over here, this one serves as a patch panel. Sometimes you're going to get a patch panel that is nicely organized, and sometimes you're going to get a bunch of jacks that would service as patch panel. So there would be wires. You can see just a tiny bit of on the bottom here. These wires, they run into the field. Field is basically the rest of the building or the rest of the facility, and they're terminated at the back of this jack in a certain way. And then these will be the patch cables that would connect each and every device into a switcher. Okay, switcher or a switch. Sometimes the switch also acts as a router, so there are different devices as well. And this here looks like a modem or a gateway or a router, or maybe this one looks like, so there are other devices to connect things to outside world. Okay, but the elements are the same. There's a field wiring, there's a patch panel, and there's network equipment that is installed here. Some of the service calls will look like this. This is one of the better of the worst situations. Sometimes you're going to have this use the wiring filled with grease and whatnot, because different shops have different environment there, right? All right. Now, sometimes you're going to see something like this. Now, that's an extreme version of that. Will be a main distribution frame, right? So this is basically almost the same as this, except it doesn't look like that because there are many of those elements structurally organized. So yeah, there will be a field wiring going to the back of those equipment racks, and there will be patch panels, and those patch panels would be connected, those ports of the patch panels would be connected to the ports of the switches or otherwise devices. Also, there would be probably what I can see here. These are those orange conduits here. Most likely, they would be fiber optic lines that would be connected to media converters, and the media converters would be connected to the cascades of switches, most likely. Okay. Now, there's some things to consider. And is consider the power required. I just want you to have some sort of imagination or imaginary knowledge of what's involved in this whole environment. It says, I said, consider the power required to service the equipment. Those big distribution frames, they require a lot of powers. Just imagine that one section like this here, there's just one section like that. It would consume or produce or consume the energy that would be equivalent of maybe 2 barbecues running full blast. So that's just the heat that is being produced by that. Never mind the energy that's being used to process the data. Now, when we consider the power to power up the equipment, because the equipment produces a tremendous amount of heat, then we need to consider the power that's required to cool down the whole environment. Okay, so not only you have to supply the power to power up all this equipment, and that's huge, you also have to consider the power that is required for the air conditioning system. If the air conditioning fails, this whole thing is going to heat up in no time to the point that it's actually not usable. All right, now let's take a look at the wiring here. You see there's so much wire. There's so many pieces of equipment. Where are all those wires? There are some cable trays here, but I don't see too many wires here in those cable trays. The wires could be somewhere at the back, but take a look at this floor. I just want you to take a look at this floor because you will be dealing with something like that as well. All right, and I just said, look at this floor at this room, which is I just pointed out. Now, there's something that's called a raised floor, and that's what it looks like. Basically, it's a frame, just like the ceiling frame, but it's instead of the ceiling tiles being held by the frame, excuse me, that's mounted to the ceiling. These floor tiles are mounted onto the grid that is set up on the floor, and this way you can just lift those floor tiles, and you can have access to the whole network. Very, very efficient system, but also very expensive. All right, now in order to lift those floor tiles, because those floor tiles, they are heavy and they are mounted, well, they have to be safe. All right, so now whenever you have to deal with that, whether you deal with the raised floor, you are going to ask the client, where are those suction cups? And that's what they look like. Right? That's how you lift the floors, the floor tiles. All right. So that's as much as LAN information as I'm going to give you at this with this lecture. Now we're going to consider WAN, which is Wide Area Network. All right. WAN joins an unlimited number of smaller networks. Just with this statement, does anything come to your mind? There's one word that you can basically substitute with this whole sentence. And the word would be, how much does one weight the floor tile? There's a question. You know what? I did not weigh it, but it needs a little tiny bit of a muscle to lift it up. It's manageable by one person. Okay, let's get back to this one here. When it says unlimited number of smaller networks. An idea of what this could be, if you wanted to describe it as just one word. Wireless, nope. Close but no cigar. All right, I'll give you a few more seconds. Combination will be one wide area network. And the routers or gateways or modems, they do have a port that is labeled as WAN, W-A-N, that you connect the wires, you connect something to it. All right. WAN joins an unlimited number of smaller networks in a way that devices of different networks can communicate with each other. The keyword is unlimited. Any word that comes to your mind? One more click. Example. If I show you there we go. All right. Luis, you got the candy. Internet, there we go. That would be internet. WAN. Yeah, gold star and a cookie for you. There we go. Excuse me. All right. So yeah, so WAN would be basically World Wide Web, internet. Yeah. Now, let's see the back of a gateway or a modem. Sometimes you're going to, if you order internet from whatever company, you're going to get in the mail. You're going to get in the mail a box, right? And when you call their tech support, they will be referring sometimes to that box as the box, or sometimes they will say the black box or the gray box or whatever. All right. Now that box can service as many different ways. It could be servicing as in a smaller venue. They would be it would service as a switch, as a router, and as a gateway, and as a modem in one box. In the bigger facilities, you will have many bigger boxes that service as one of each as a separate box. Okay. Now let's analyze those ports here. Okay, well, power adapter. Okay, well, no big deal here. Reset button. Well, if things don't work, that would be the first one I would press just to reset the whole thing and see if things come back to normal. And then we have some Ethernet ports here. These 2, 3, and 4, LAN, LAN, LAN. So LAN port 2, LAN port 3, LAN port 4. This is where you would connect either. You can connect an individual device, such as computer or a wireless access point or whatever thing that works on the network. Or you can connect a switch or a hub that would be able to service through that one port. You could have an 8-port switch or a hub that would service 8 computers. Of course, the speed and the bandwidth would have to be divided by whichever amount of the devices this thing has to service. Right? Then the LAN 3 is the same thing, LAN 4 is the same thing. Then this one here, all right, is LAN/WAN port. In this particular device, the port number 1 can service as LAN, so you can connect another computer or a switch into it, or you can connect that to a gateway. That will be the gateway to your to the rest of the world, or you can connect that to a modem. So you would not use this device as a modem. You would use this device as a router or a switch, or if you connect depending on the configuration. So there are different scenarios you can connect to this device. Now, also, there's one last port that says DSL. Do we remember what DSL stands for? DSL, something to do with the dry loop, not a hard loop, but dry loop. It has to do with the telephone line. When the internet, digital service, same thing, line. Yeah, well, digital subscribers line. That's basically what it stands for. And that would be a telephone line that would carry the internet signal. Sometimes the telephone line carries also a voice signal, but this would be if it were a dry loop, then there would be a telephone line that would carry only the DSL signal, which is the internet. So this is just a little bit of analysis on how some of the equipment is connected. All right, wireless LAN. Wireless can exist on its own or could be a part of the network. Like, for example, in our school, we would have hardwired connections that connect the computers to the switches through Ethernet wires, copper links. And we also see those white boxes that service as wireless access points. And that wireless access point is connected to a switch. It's hardwired. It's wireless, but it's wired, okay? That's the paradox of things. That wireless access point is still wired, hardwired into the switch. And it services things like our cell phones, our laptops. Basically, it's the Wi-Fi, wireless access point. As the World Wireless suggests, this is a type of a LAN that uses wireless networks protocols to establish communication between devices. Right? Is it possible to have 100% or almost 100% wireless network? Well, yeah, sort of. Most of the residential systems, you would get a box, and you would connect that box to the wall, and then you would log in with your login name and password into that box, which would be a wireless device. So it is possible to have something like that. All right. Or one can be a part. Yeah, so this wireless LAN also can be a part of the bigger LAN, such as in our schools and most networks. Any fast food places or restaurants, they have their own wired networks, and they also have Wi-Fi devices or wireless access points or access points. So they could be WAPs or APs. WAP stands for wireless access point, and AP stands for access point. It's the same things. Different companies name things a different way. All right, and that's what it looks like. By the way, in our school, I think we're using the Cisco devices. If you see the light on our devices, if you see the light that is green, that means nothing is tapped on wirelessly onto the device. Nothing is using it. As soon as you see the light that's blue, that means that something is using that. So somebody could be within the proximity with their cell phone that you're connected onto the school's network, or there could be a laptop that somebody's logged in with and it's using, actually it's connected wirelessly to that particular device, and so on. But also, when you see that the light is flashing, it's either there's some error or this device was powered off and it's rebooting itself. Those are also very common devices in public spaces such as stores, department stores, fast food places, restaurants. Hot dog cards don't have those yet, but who knows, maybe in 10 years they all will too. Okay. Yeah, so can you spot wireless access point? I wrote this thing in 2019, so you will see the 2019 here. Dates. Can you tell what different status of the colors indicate green or blue? So this is basically what I just told you. So when you walk around the school hallways, take a look. They're all over the place. And there's an example of a conference room wireless system. There would be two wireless access points, and people who are coming into the meeting or business meeting, whatever else it is, they could log on to those. Metropolitan area network. All right, a network spanning a physical area. Span definition, something such as railroad, trestle, or bridge that extends from one point to another. So it's a network covering a physical area larger than LAN, but smaller than WAN, of course. Yeah, it's larger than LAN because it's a metropolitan, it's a city network, such as city. Right? A MAN is typically owned and operated by a single entity, such as a government body or a large corporation, such as city. Okay. I have to put references on because sometimes I get definitions and things from internet, and if I get them from some sources, I have to include those sources. All right. So let's say, for example, traffic lights and the city cameras. The traffic lights are being controlled. They're just not running just press of a button and there's a timer for the traffic lights. It used to be like that maybe some time ago, but now all the traffic lights, for example, are synchronized by the city hall, and those traffic lights are connected excuse me, to the metropolitan area network. And you're going to see quite often, you're going to see something that looks like a wireless access point, and basically it is a wireless access point with the antenna on it. So some of the traffic lights are not wired; they're wirelessly connected to the metropolitan area network. All right, enough references. Okay. SAN, System Area Network. Links Performance Computers. This is a system or storage area network. Service, it's mostly for data storage and data retrieval system. So it's not available usually it's not available to the regular public. Those storage area networks are available to certain companies through something like VPN, which we're going to study in the next few slides. If they're high-speed connections, because there could be a company that has another facility somewhere in a different city or different part of the world, and the data that has to be retrieved needs to be retrieved fast. So usually there will be high-speed systems. Examples, I don't know, hospital records, police records, whatever else they would be using something like that storage networks. And now not everybody can log into it. You have to have special rights to use those, of course. All right, and there will be a cluster configuration, also known as cluster area networks. All right, here is an example of, this would be called a client or a user. And this user has special rights to access things in Paris or New York. But this whole thing is a storage that is services basically one company. Now, it's a commonly used practice that, for example, there's a huge main, let's say a school board, okay? School board would have all the student and staff information, employee information stored on the storage area network, and that would live in the main, let's say, Board of Education building. Okay, but what happens if that building is destroyed? Things happen. Buildings catch on fire, whatever else could be a disaster. So that will be destroyed. So what happens is that those storage servers are basically cloned and copied and distributed around other schools, for example. So there will be a high school that would have a huge network room, and part of the network, part of the network system, they will have few servers that have nothing to do with the school, but they will have storage servers that basically are synchronized with the mainframe, and there could be more than one. So the data is not lost. That's the purpose of storage area, one of the purposes. Okay. Storage area networks. Well, that's for the corporation type of usage. Now, there are other purposes for the storage area networks. So okay, what do they say here? Direct accessibility to the service, indirect or conditional accessibility to clients. So let's see what would be the example of that. End client might access storage area data, and it could be subject to conditions. Like, for example, a client could purchase certain type of services, um, and then once they pay money, they can view some of the content. Well, let me see here. Example here. Well, all right. Local television service provider. All right. I don't know. I keep saying that every year and people find that funny. So I'm going to say it again. Somebody stole my picture and put it on the internet. Oh, wow. Okay. Somebody's in trouble. Anyways. Okay. So this will be one of the ways of using storage area networks that's available for client based on certain conditions, such as paying money for the service. So let's analyze the signal path for that. Here is a happy family gathered around a television set. All right. Now that television set is connected to the box. It will be the TV box, which in other ways, it's nothing else but a router and a modem in one place, in one box. That box is connected to a modem. Sometimes that's what it works. Sometimes there are two different pieces. Sometimes there's just one piece that plugs into the wall. Now that modem is connected to the cloud, which would be the internet or the WAN, wide area network. So that's from one side of the signal path. Now let's take a look at the other side of the cloud. What happens there? All right, system area network, storage area network example. From the cloud, the signal goes into the signal routing system at the local TV service provider. Then that device would be connected to some form of a media retrieval rack, and that will be the front view, and that will be the rear view of that rack. And that rack, basically, it's a magnified version of that. It has a bunch of hard drives. Like, for example, this rack contains 230 hard drives. Each storage drive is capable of 1.8 terabytes, full of movies, shows, and other audiovisual content. So when you order a movie on demand or something like that, that's basically what happens. That's the way of the signal routing. VPN, virtual private network, a secure tunnel between two or more devices. VPNs are used to protect private web traffic from snooping, interference, or censorship, or basically otherwise access. Okay, let's keep going. Large corporations use VPN technology to link facilities located in different geographical locations. example of that would be the whole money transfer system. So all the money machines, all the banks, all the stores, cash registers and whatnot, they are connected to each other. The systems are interconnected via virtual private network that only they have. It's a part of the internet designated just for them based on the money that they pay, right? And only they can access the virtual private network. That's another visual of that. Okay, once you download this, so you can basically analyze this picture based on what I said. All right, let's just see here another example of virtual private network. Here's a map of the world, and this would be one big company that has facilities or plants all around the world. Now, this company has to function as one big whole company, so the network is connected through VPN. It's a virtual private network designated. It's a chunk of the internet that is supposed to serve as private space on the internet. Only those companies have access to that. All right. So remember when we talk about VoIP systems, the voice over internet protocol, the VoIP telephone systems, this VoIP system and this VoIP system and this VoIP system that they have, they're connected to each other via VPN. So if somebody wants to call somebody who's sitting in this window here, this office, to somebody who is sitting in that office, they can dial straight their extension number, and through VPN, which is through internet access, VPN wise, they can connect to each other without even having to make a long distance call or having to select outside line. It all goes through VPN, and this phone call is not considered to be long distance, even though someone from Asia wants to talk to somebody from Canada. There's no difference between them calling from here to here or someone calling the other person who is just sitting next cubicle to them. Okay, so that's the idea of VPN. Can we exist without internet? I'm not going to play you that little humorous link. You can click on that. Well, this is a bit of humor in this one, but can we exist without internet? Well, a few years ago, was it 2006 or 2007? There was that big brownout or blackout. Well, I not the one thing that was the whole thing was paralyzed. Internet did not exist because everything was just power went off everywhere. You couldn't go to a variety store and buy a chewing gum because the internet was down. Now, in later previous years, you could because they have those mechanical cash registers. Nothing was connected to internet. Yes, you could. You just give money. But now we have become so dependent on internet and so dependent on the networks systems that basically when the network goes down, we cannot exist as anymore as in a corporate world. Which for people like us, it's a sort of like good news because there's jobs for people like us to service all those and install and dismantle and service again and install again. There's a lot of business going on using the when it has to do with network service. And it's not always just setting up the IT. It's basically installing the hardware, configuring it in such a way. And I'm showing you how to configure this from the hardware point of view. All right, there's another couple links that have to do with the way that we're going to terminate jacks. Last lab that we performed, and everybody has done it now, that lab is ended. We connected an RJ45 jack or Ethernet jack in the USOC configuration, which will be a single line telephone. Now, today, the first group, we're going to be beginning a new lab. We're going to connect a 25 pair cable onto a BIGS frame. So don't be late for this class. There's a lot to be learned, and there's going to be a lot that I have to explain and demo. and explain to you the evaluation process, and stage by stage we're going to complete. We only have 2 hours to do this, so don't be late. Now, I think this is the end of this presentation, and I will see the first group today and the next group tomorrow, and the week after there's going to be another 2 groups I'm going to see. So for the next 2 weeks we're going to be connecting 25 pair according to the color code. The only thing I have posted on web is the evaluation rubric. So once you get into the room, you can log into the computer and pull up that evaluation rubric. So as you're doing it, you can pay attention to those criteria. But also, I'm going to explain in detail, in person, things that we have to do once you go to class. All right. So the class has ended right now. It's 10:56, almost 11 o'clock. We got the full hour, and in a couple hours I'm going to see some of you, and the rest I'm going to see you other days. Okay, any questions about anything that we have talked about today? I don't see anything. Well, if something comes up to your mind, by all means send me an email or ask me during the lab. Okay, I'll see you when I see you. Thank you, and keep safe and have fun. Something like that.